Okay, let's talk about doing a kinetic analysis of running. And when we do our kinetic analysis of running, we identify all forces acting on the object, not by the object. Remember, we'll do our mental gymnastics because we are interested in the forces created by the person. But in order to do that, we actually analyze the forces acting on the person. All right, so this is my badge stick figure of a runner. It's in contact with the ground. He or she, this is the swing leg, this is the stance leg, and what forces are acting on the person? Well, the force, and I'm gonna draw the center of mass, the force of gravity is acting on the person, and what's important about this force is it's a vertical force only. So we only concern ourselves if we're going to do something in the vertical direction. Now, the next force I'm going to draw is I'm going to draw a little tricky, and I'm going to draw the ground reaction force. Any pushing or pulling, I'm going to draw it at an angle, and this doesn't really correspond well with the picture, but this is the resultant ground reaction force. It is a three-dimensional force acting in the anterior-posterior direction, the vertical direction, and the medial-lateral direction. What we will do is we'll always decompose this ground reaction force into one of those dimensions and then understand the kinetics and kinematics in that dimension. So the way I've drawn this, I can draw out the vertical component and the anterior-posterior component. Okay, I'm not going to be able to draw the arrow very well here so you can see it. I've just got black marker, but I'm going to draw it as a thick line here. And I guess I'll do the same here. Okay, and then this is FGRF AP, anterior-posterior. This is FGRF vertical. Okay, so we take this resulting ground reaction force and we break it into the two components, the vertical and the anterior posterior. All right, any other pushing or pulling going on the runner? Well, one that we're going to ignore right now is air resistance. Air resistance is a real force. It's a real push. And if you're running into a headwind, you can feel that wind pushing against you. And this is a factor that will ultimately influence running performance. It could be a headwind or it could be a tailwind. And there are rules in running in terms of how fast the wind can be for a certain world record to be allowed. Headwind obviously doesn't matter, but tailwind, it does matter. But for now, I'm not going to deal with air resistance. We'll deal with that later on in a more detailed presentation on factors that influence running performance. So that's it. So I have these two forces, force due to gravity and the ground reaction force. This ground reaction force is actually acting in three dimensions: the anterior posterior, the vertical, and then also the one I'm not drawing is the medial lateral, which is coming in and out of the page. Now, interesting detail, the way I've drawn this anterior posterior curve is in that direction, which would be a negative force. Remember, our convention is always up is positive and forward is positive. Okay, that's the way I've drawn this ground reaction force right now. If I take another piece of paper and I draw out a runner later in stance, where the person is close to takeoff, and the person is swinging the other leg forward. Oh, that's not a great picture, but the person's moving in this direction, and now this is close to takeoff. The resultant ground reaction force will actually be pushing in this direction. And then the horizontal component of this is right here. And then the vertical component being down here. That horizontal component is now pushing in the same direction of movement. So that anterior-posterior ground reaction force will be positive. And so we have a situation in looking at the horizontal movement where the horizontal ground reaction force can be either negative or positive. So remember, we do one dimension at a time. So let's draw out those equations. Sum of forces acting on the object equals MACOM. In the vertical direction, we have F sub G and we have FGRF. Those are our two forces acting on the person. Back to our picture. And those add up to MACOM in the vertical direction. Okay, that's vertical. That's our equation, or FGRF, this is the other way we're looking at it, equals MACOM in the vertical direction plus body weight. In the horizontal direction, and I should be specific in anterior posterior as opposed to medial lateral. I won't do medial lateral. It's pretty unique for each runner. Anterior posterior, what forces do we have acting on the runner in the horizontal direction? Just the ground reaction force. That's it. And in either picture, the only horizontal force is the ground reaction force component in the anterior posterior direction. Again, taking air resistance out of this. If air resistance were a force, I need to include that. So now I have FGRF AP. I add up all the forces in that direction, which means my equation is going to be FGRF AP equals MACOM AP. So the acceleration of the center of mass in the anterior posterior direction is going to be directly proportional to the anterior posterior ground reaction force. Notice note direction can be positive or negative, depending on where we are in stance phase. Either negative, either positive, causing propulsion, or negative, slowing the runner down. All right, we're going to do that analysis in just a bit. Sometimes people will say, well, where's friction? Well, friction is just a name for force. In this case, this is the friction force. This is the force pushing on the person, and it happens because there's friction between the foot and the ground. If there was no friction, for example, trying to run on ice, then there would the foot would just slide along here, and there would be no ground reaction force in the horizontal direction. The ground reaction force in the anterior posterior direction is in reaction to the person pushing on the ground. So we strike the ground and we're pushing on the ground in that direction. The ground reaction force is opposite to that. We only put the ground reaction force into our kinetic analysis equation. All right, so these are our two general equations for doing the kinetic analysis of running. We would have a third one if we wanted to do horizontal movement in the medial lateral direction. And then we would have ground reaction force in the medial lateral direction is equal to mass times the acceleration of the center mass in the medial lateral direction. I'm not going to do that right now because I'm only going to focus on both the vertical and anterior posterior movements of running. Okay, thank you.